Good morning to all. Welcome to today's session. Today we are going to see the revision for the second chapter, okay, for PA2 examination. So the topic of the lesson is polynomials. So in the last class we have seen the revision in chapter 1, and I hope so you should understand, that is you have understood whatever it is we have seen in the last video, okay, under the first revision, under the first chapter number 1. And today we are going to see that we are going to revise the important basic definitions of everything under polynomial here, okay. So the general form of the polynomial, already we know that is the general form of the polynomial is P of x equal to a0 plus a1x plus a2x square plus etc. plus an x to the power n. So that is a general form of a polynomial, we know that. So here a0, that is a0, a1, a2, everything are real numbers. Real numbers. And the power, okay, so power of the variable. So power of the variables all are whole numbers. That is very important, okay. So whole numbers. If an expression which contains the power of the variable as whole numbers, that expression is said to be a polynomial, okay, otherwise not. For example, so P of x equal to x plus 2 and P of y equal to 1 plus y square. So this is the example for the polynomial. So here this bracket, that is stands for the variables. Okay, so here the expression which contains the variable x alone means it is denoted by P of x, and the expression which contains the variable y means it is denoted by P of y, like that. And what about this one? P of x equal to x to the power 1 by 2 plus 3. So it is not a polynomial because the power of the variable is 1 by 2. It is not a whole number. So that's why. And what about this one? P of x equal to 1 by x plus 5. So here x is in the denominator. If you transpose this into the numerator, it will become x to the power minus 1 plus 5. Right? So here the power minus 1 is there. So it is not a whole number. It is an integer only. Therefore, it is not a polynomial. Okay, this is the example of the polynomial. Okay, and types of the polynomial. So we can split the types of the polynomial according to the terms and according to the degree. Okay, so according to the terms and according to the degree, and according to the terms, how can we classify the polynomials? So here, according to the terms, if it contains only one term, means it is known as monomial. Okay, and the polynomial which contains two terms, it is called binomial. And the polynomial having three terms mean it is called trinomial. Trinomial, okay. And four or more, generally we can call polynomial. Polynomial, okay. Then according to the degree, so if a polynomial having first 1 degree means it is called linear polynomial. Okay, linear polynomial. And 2 degree means it is called quadratic. So quadratic polynomial. And the power 3 means cubic polynomial. Cubic polynomial. Okay. And then above 4, 5 means 4th degree, 5th degree, like that. So here degree is there given here. What is degree? How can it define the degree of the polynomial? The highest power of the variable. So highest power of the variable in a polynomial. In a polynomial is known as degree of the polynomial. Okay, for example, P of x equal to 1 plus x square plus x cube. means the degree of the polynomial is 3 here. Okay, and it is called a cubic polynomial. Okay, so these are the types of the polynomial according to the terms and degrees. Okay, next is division algorithm. So division algorithm, how can we write in polynomials? Okay, for example, in numbers, for example, if you divide the number 8 by 5 means what about the quotient? So 1 5s are 5, remainder 3. So here the quotient is 1 and the remainder is 3. So we can write this as 8 equal to 5 into 1 plus 3. That is divided equal to quotient. So quotient into divisor plus remainder. So we can write like this for every positive integer. So every positive integer can be written like this. This is called a division process for integers. Okay, so here division algorithm for polynomials. So in polynomials also we need the dividend polynomial, divisor polynomial and everything. Okay, so let P of x is any polynomial. So P of x is any polynomial. Okay, and if you divide P of x by any other polynomial G of x, okay, if Q of x is the quotient and R of x is the remainder, means we can write P of x equal to G of x into Q of x plus R of x, and the remainder is always equal to 0 or greater than 0, but should be less than the divisor. Okay, should be less than the divisor. So we can write this G of x. Okay, so this is known as division algorithm for polynomials. So here P of x is the dividend polynomial and G of x divisor polynomial, Q of x quotient polynomial and R of x remainder polynomial. The limit of R of x, that is 0 to and G of x. Okay, this is called division algorithm. And division of one polynomial by another polynomial. Okay, so how can you divide one polynomial by another polynomial? Let us see one example now. So now I am going to divide 2x cube plus 7x square plus 2x plus 9 by 2x plus 3. Okay, by 2x plus 3. So how can we divide? So the division procedure is nothing but we can divide the first number by the first number. Already I said, that is 2x cube divided by 2x. Okay, so here 2 get cancelled and x here power remain 2 is there, so x square. So when we so x square is the first term of the quotient and multiply this one with these two numbers. So the first term will come as it is, and for the second term, so plus, so 3x square, and after writing this one, so change the sign of the down expression. Okay, and this get cancelled each other. What about here? So plus 7 minus 3, so plus 4 will come. So with the variable, write the variable as it is, plus and down the other two terms. So 2x plus 9. So next we should write the next term of the quotient, so that again divide the first term by the first term. So 4x square by 2x. So 1 2s are 2, 2 2s are 4, and x square 1x cancel. So 1x will be there. So 2x power 1. So plus 2x to the power 1. So no need to put power 1 and multiply this 2x alone with these two numbers. Okay. So when we multiply 4x square, the first term will come as it is, and for the second term, so here 3, here 2x, so 3 2s are 6x, and change the sign of the down expression. So minus, here minus, so they get cancelled each other. What about here? So minus 2, so plus 2 minus 6. So plus 2 minus 6 means minus 4x plus 9. Okay, so again for the next term, so before writing the next term of the quotient, just to check the remainder of, so just the degree of the remainder and degree of the divisor. If the degree of the remainder is less than this one means you can stop the procedure, otherwise you can continue. So here degree of the remainder is 1 because x to the power 1 is there, and here also x power 1, so both are same degree, so continue. Okay, so for the next term you can divide the first term by the first term, so minus 4x power 1 divided by 2x. So x get cancelled here one time, here 2 times, so minus 2. So write minus 2 is the next term of the quotient and multiply with these two terms. Okay, multiply 2 with these two terms. Okay, so the first term will come as it is, that is 4x, and plus it minus minus, this plus here minus, so minus 3 to the 6, and change the sign here, so plus, here also plus, so this term will cancel each other, so here 9 plus 6, 15, so the degree of the remainder is 0 and the degree of the remainder is 1, so 15 we can stop the procedure, so 15 is the remainder, so remainder equal to 15. What about quotient now? So quotient equal to, so this one. Okay, so this is the quotient, so x square plus 2x minus 2, that is the quotient. So that is a procedure to divide one polynomial by the another polynomial. Okay, and for one more sum, now I'm going to write one more sum here, that is x cube minus 6x square plus 7x plus 6. Now I'm going to divide this by x minus 3. Okay, how can we write first term? First term by first term. So x cube by x is nothing but, when we cancel it, x square. So x square is the first term. So when we multiply this with these two terms, the first term will come as it is, and second term minus 3 into x square, 3x square, and minus here plus. This get cancelled each other. What about here? 6 plus minus 6 plus 3, so minus 3x square, and down the two expressions here, so x plus 6, and then for the next one, divide the first term by the first term, so minus 3x square divided by x, so 1x get cancelled, so minus 3x only will come, so minus 3x. When you multiply minus 3x square, so plus into minus, so here, okay, so minus into minus plus 9x, so subtract it, so here plus, here minus, they get cancelled each other. What about here? So plus 1 minus 9, so minus 8x, and plus 6, and again first term by first term, so minus 8x by x, so here x is cancelled, so minus 8 only. So when you multiply with the minus 8, it will become minus 8x, and minus into minus plus 8 3s are 24. So change the sign, here plus, here minus, so they get cancelled each other. So 6 minus 24, so minus 18. So here also the remainder is, the degree of the remainder is 0. Therefore we can stop the procedure here itself. Therefore remainder equal to minus 18, and quotient, so quotient equal to x square minus 3x minus 8. So that is the quotient. Okay, so that is a procedure to divide one polynomial by the another polynomial. So here, so x square minus 6x square plus 7x, so x plus 6. Okay, so the remainder may be 0 or non-zero number also will come. Okay, according to that. But when you should stop the procedure means according to the degree of the remainder. If the degree of the remainder is 0 means you can stop the procedure, or the degree of the remainder is less than the degree of the divisor means stop the procedure. So however, in each stages you should find the degree of the remainder. Okay, so here in the first stage the degree is 2, but the degree is 1, so it is maximum, so continue. So here the degree is 1, here also degree is 1, so they are equal, so I continued here. But here degree is 0, here degree is 1, so this is the minimum, so stop the procedure. So that I stop the procedure here. Okay, so let us see remaining sums in the next video.